Here's another example of verifying an identity. This is probably one of the more tricky ones, but it has the general same setup all the time. Here you have one term on the left, one term on the right. They're both fractions. They both have cosecant and cotangent in it. When you see something like this, there's only one thing that's going to work, and that's to conjugate the top and or conjugate the bottom on this side. So I'm going to choose to work on the right-hand side because I've done the left-hand side in class. So I'm going to multiply top and bottom here by the conjugate of the denominator. So I'm going to multiply the denominator by cosecant of t minus 1. And another way of looking at this is I'm forcing the denominator to have this factor of cosine t minus 1. Oh, I'm sorry, not the denominator, but the numerator to have it, because the other side also has it. But it also just works to think of conjugating. So this is going to equal, and I'm going to leave the top alone. It's going to be cotangent of t times cosecant of t minus 1 all over, and then when we multiply this out, it's going to become cosecant squared t minus 1, because they are a difference of perfect squares. Alright, but cosecant squared minus 1, that sounds familiar. That would be this identity rewritten as cotangent squared x is equal to cosecant squared x minus 1. So I can replace cosecant squared x minus 1 with cotangent squared x. So this whole piece here is cotangent squared x. So this equals cotangent t, I'm sorry, not x, but t, times cosecant t minus 1 over cotangent squared t. And here we have common factors top and bottom. It's one term on the top and one term on the bottom. I can cancel. So if I get rid of one factor of cotangent, we're going to have cosecant of t minus 1 over cotangent t. And that is the other side. So we're done with that one. Alright, finally, this ugly mess. Obviously we know which side's uglier. That's going to be the left-hand side. Plus there's only one term on the right-hand side, so I want to force this side to become one term. We're going to need a common denominator. So we're going to multiply top and bottom over here by cosine of x. And we're going to multiply top and bottom over here by sine of x. That seems nice and easy. But then the numerator becomes, well, a bear. Alright, distribute it out, write it over one common denominator. We're going to have sine of x, cosine of x, plus cosine squared of x, minus, and we've got to be careful over here, this minus is going to get distributed. So it's going to be minus sine of x, cosine of x, plus negative times a negative, sine squared of x, all over sine of x, cosine of x. Now one of the nice things is the sine of x, cosine of x are going to cancel. One's positive and one's negative. We have this cosine squared plus sine squared, that's just going to equal 1. Oh, this is easier than I thought it would be. So this would be 1 over sine of x, cosine of x. And if we split this, because we have, basically two terms over here, or product of two different things, I can write this as 1 over sine of x times 1 over cosine of x. And this will give us cosecant of x times secant of x. And the multiplicative property of, commuting, we can flip that around and actually we have the other side.